Hi, hello guys. Hello, this is lab number 7, physics 211 lab. So in this week lab guys, we will try to design a force meter. So this is force meter, and also we will try to calibrate this force meter. And then guys, we will try to use it and test it. So we will use a small car with a fan, and then we will try like how much force this car can exert on this force meter. Yeah, that's great. So it is simple, guys. So what I have here, I have roller, as you can see. I have a pencil right here. Yeah, and I have string right here to hang this force meter, which is right here. And here I have spring, so you can see the spring is free like this. And right here I have indicator. So this indicator can show me how like how long distance do we have here. So yeah, and then we will calibrate this force meter. So right now this force meter can read distances, but we will calibrate it and make it measure force, which is measured in Newton. Yeah, so yeah, it is simple guys, simple. As you can see, you can make one if you would like, and you can finish the whole worksheet using your own force meter. Or what you can do guys, you can follow my video and copy the data that I will collect and finish your worksheet. So that's enough. The most important thing guys is to understand what does force meter mean, and how can we use it. Great. So this is the force meter guys. Let's now start calibrating this force meter. To calibrate the force meter guys, what do we need? We need balance. As you can see here, we have a balance. We have couple weights here, so 1, 2, 3, 4 weights. And of course we have the force meter that we designed. Yeah, again, I will repeat that guys. If you are able to make force meter, so that's great, make it and use your own data using your own force meter. If you can't make it, so that's fine, just use my data guys. You don't you don't have to. Okay, so we have everything right now to calibrate the force meter before we use it. So let's get started now and calibrate the force meter. Okay, now guys, we will start to weight these weights before we start to calibrate the force meter. So let's start with the first one. So this is number 1. And I will start the balance here. Okay, so it will measure the weight in ounces. So let's see here. So it's 4.1 ounces. So weight number 1 is 4.1 ounces. Great. So we know the weight for weight number 1. Now I will move to number 2. So this is number 2. Okay, I will put it here. So it is 4.3 ounces. So number 2 is 4.3 ounces. That's great. Now I will move to weight number 3. So I will write here 3. Let's see what do we have. So we have also 4.3 ounces. So for weight number 3, we have 4.3 ounces. Okay, that's great. And then the last one here is weight number 4. So let's write here number 4, so we don't get confused. Okay, so number 4. So what do we have? We have exactly 4 ounces. Yeah, maybe that can help you to see here. Yeah, so 4 ounces. So weight number 4 is 4 ounces. That's great. So these are the weights, guys, as you can see. So for weight number 1 is 4.1 ounces. Weight number 2 is 4.3 ounces, and weight number 3 is 4.3 ounces, and weight number 4 is 4 ounces. That's great, and we will convert them to grams or kilograms. But for now, let's have them like this. Let's now continue to the next step, guys. Okay. Okay, guys, so now we will start calibrating this force meter. As you can see, I hanged the force meter. And as I explained before, it has a spring, it has indicator that can give us delta X, change in length right here. Yeah, and roller here. It is divided in centimeters. So that's great, guys. So what do we need to do now? We need to record the distance that we have here. So it's around 1.5 centimeter. So the 1.5 centimeter is the 0 centimeter. The 1.5 centimeter that we have here, it will be considered as 0 centimeter. Okay, so now we will start adding weights and see the distance here and measure the distance. So what I will do here, I will have this hanged here, and then I will start with weight number 1. So weight number 1 is 4.1 ounces. I will add it right here and release it slowly and see the change in length. So we don't need any vibrations here. So the change in length approximately here is 3.5. So with 4.1 ounces, we have 3.5 centimeters. Actually, we will subtract 1.5 centimeter from 3.5, but let's keep that to the end. Let's continue now. And now we will do weight number 2. So weight number 2 is 4.3. So let's add the 4.3 right here and see the change in length. Let's do that. Of course, do that slowly. We don't need any vibrations. So let's see, what do we have here. Actually here we have exactly 6 centimeters. So 4.1 centimeters plus 4.1 ounces plus 4.3 ounces, so that's 8.4 ounces, and we got 6 centimeters. Now I will add the other weight, which is weight number 3. So weight number 3 is also 4.3 ounces. So I will add it right here, slowly, very slowly. We don't need any vibrations. Great. And now we need to approximately get, so here we have around 8.5 centimeters. So now we have 8.4 ounces. plus 4.3 ounces, so that gives me 8.5 centimeters. I will organize this data for you guys, but let's continue. So this is the last weight that we will add, which is weight number 4, and actually weight number 4 is 4 ounces. So let's see what do we have here. So the distance is 10.5. So 8.4 ounces plus 4.3 ounces plus 4 ounces, so that gives me 10.5 centimeters. So that's great, guys. Now we have different weights with different lengths right here. I will show you guys what we will do after this step. So this is the data, guys, that we got for today. So we know that the 0 point here will be considered as 0 centimeters, so we need to subtract 1.5 from each one of these. So we need to have 3.5 minus 1.5, 6 minus 1.5, 8.5 minus 1.5, and then 10.5 minus 1.5. Yeah, so here we have like 4 data points. We have weights right here. We have distances right here. So what I will do right now, guys, I will try to plot it. I will convert the ounces to gram and or kilogram, and I will convert the distances here to 2 meter. And the other thing, guys, that I need to do before I plot, I need to multiply the gravity by these weights. So we need to have mg as a force, because don't forget, we try to calibrate the force meter, so we need to have forces versus distances. So then we can calibrate this force meter that you see right here. Yeah, so let's plot data. I will convert everything and make it ready for you guys, and let's see what do we have, and then plot it, of course. Now the final test, guys. After we calibrated the force meter, I will try to measure how much force can this car exert. Yeah, it has a fan right here, so what I will do, I will just start the fan and keep the car pull this string right here, so that will expand the spring right here, and we will see how much force we need. What do we need to do? We need to write down the distance that we have right here and then compare it with the plot that I showed you. So let's get started, guys. I can see like around 1.7. Yes, so I can see around 1.7. So the distance, guys, that I collected from here, it was 1.7 centimeters. So I will write it down here with this car. So we have 1.7 centimeter. Yeah, so we got this distance right here. So now we can convert this distance to have the corresponding force. But before that, we need to subtract 1.5 centimeters from this distance. Yes, so let's go back now, guys, to the plot and try to figure out the corresponding force for this car.